Let us take some problems on the topic of friction. I am marking question number 1. We will read this question first. For the arrangement as shown in figure, calculate value of force P to be applied in order to avoid the block from sliding down. Take mu is equal to 0.58. Here the diagram has been provided. So this is a question of friction and we will write the data for this question. We have to write the data for question number 1. Here the diagram is given first of all. Here we have an inclined plane whose inclination is given as 40 degree. This is 40 degree. Over this 40 degree inclined plane, there is a block kept. The weight of this block is acting in the downward direction. Its value is given as 600 Newton. Next, here we have to calculate the force P required to prevent the block from sliding down. Now, what is the meaning of the block sliding down? If you look at this diagram, here we have weight 600 Newton acting downwards. Since this weight is acting downward and it is applied on an inclined plane, this 600 will have two components. One will be parallel to the plane and the other component will be perpendicular to the plane. Now, we need to know the angle made by this force, or you can say weight 600 Newton with respect to vertical. We need to calculate this angle. Now, see here, if this angle of the inclined plane is 40 degree, here we have this as 90, so the remaining angle becomes 50. Even this vertically opposite angle is 50 and here we have 90, so the remaining angle becomes 40. This is 40 degree. Means weight is making an angle of 40 degree with vertical. Now we will have two components of weight 600 Newton. The first component is parallel to the plane. This parallel component will be given by 600. Since inclination is with vertical, so this will be sine 40 degree, 600 sine 40 degree. Next, the vertical component, this will be 600 cos 40, it is 40 degree. I hope you all are getting this. Now, since the component of weight 600 cos 40 will try to keep the block in contact with the plane, opposite to that we have normal reaction which is called as R suffix n. Now, because of 600 sine 40, the block will try to move in the downward direction, but there will be one friction force which is called as F is equal to mu into Rn. This is the value of friction force. This friction force will try to keep the block in the opposite direction to motion because motion is in the downward direction. So because of 600 sine 40, this block will be sliding downwards, but friction force would try to oppose it. Now we need to find the value of force P, which we will be applying in the upward direction so that the block does not slip down. So this is the question wherein we have to calculate what is the value of force P that should be applied in order to avoid the block from sliding down. Here coefficient of friction mu is given as 0.58. So these are the conditions which are provided in the problem. Now let us try to solve this question. I'll write solution here. Since we have number of forces here, for friction problem we have to start with the conditions of equilibrium. I'll say that using the conditions of equilibrium, here I will be using the equilibrium conditions. First condition that I will be using, it would be called as summation of fx is equal to 0, where all rightward forces would be taken as positive and all leftward forces will be taken as negative. While writing summation fx, I will say that this is the sum of all forces parallel to the plane. If we look in this diagram, we have to just take forces parallel to the plane, add them, that will be our summation of fx, and then we will be equating it to 0. So now I would be saying that therefore summation fx is equal to, if we look for forces along the plane, the meaning is it is parallel to the plane. Here force P is parallel to the plane, F is parallel to the plane, and 600 sine 40 is parallel to the plane. So all upward forces along the plane should be taken as positive and downward forces should be taken as negative. So here I have P plus F minus 600 sine 40 is equal to 0, my first equilibrium condition. In this, I will be keeping P on one side because we want to calculate P, the value of force here, and I will shift these terms on other side. So I will have this as P is equal to 600 sine 40 degree minus F. It means I have shifted 600 sine 40 and F on the other side of equal to sign. Therefore, I will say that P is equal to 600 sine 40 degree minus F. F is equal to mu into Rn. Here we have the formula in which we can say that frictional force is equal to coefficient of friction multiplied by normal reaction. Hence, capital P will be equal to 600 sine 40, the value which I have it is 385.67 minus mu is 0.58 into Rn, normal reaction. I'll keep this as my equation number 1. So from solving forces parallel to the plane and equating them to 0, I get an equation of P. And here in this question, they have asked us to calculate the value of capital P. So if we know Rn anyhow, then we can easily get the value of P. So after using summation of fx, I will say that now, using the second condition of equilibrium in which we have summation of Fy is equal to 0, upward forces will be treated positive, downward forces will be negative. So I'll say that what is summation of Fy? It is the sum of all forces perpendicular to the plane, and that should be equal to 0. Now if we look at forces perpendicular to the plane, here I have Rn, which is perpendicular to the plane, we can say it is perpendicular to the plane. Rn is upward, so it will be treated as positive. Then 600 cos 40, it is downward, so it should be treated as negative, minus 600 cos 40 degree is equal to 0. Therefore, Rn will be, I will shift 600 cos 40 on the other side, calculate the value. So Rn comes out to be 459.63 Newton. Once we have Rn, we can put it in equation number 1 and get the value of capital P. So after getting Rn, I will say that put Rn in equation 1. Therefore, capital P will be 385.67 minus 0.58 into Rn, which is 459.63. Hence, if I calculate all the terms here, I will be getting my answer of capital P, and that comes out to be, from this I can say capital P is equal to 119.09 Newton. And if we look at this question, it was asked to calculate the force P required to prevent the block from slipping down. So if we see this, the force that will prevent the block from slipping down, it is 119.0 Newton, and we complete the first problem.